So we just figured out how to add polynomials, like these engineers are probably doing here as they're designing something. But multiplying polynomials is also as important, maybe more important. So let's check out some multiplying polynomials. Well, when we have two polynomials and we're multiplying them here, like here we got a binomial times a binomial. Well, one useful tool is called a area model. So when we're finding the area of a rectangle, remember, so area of a rectangle, if you got a rectangle that is 3 by 5. The area is 3 times 5. So when we think of area, we think of multiplication. And when we think of multiplication, we can think of area. So here's what we can do. Let's take this, these two expressions here. We've got 2x minus 3, and we're going to write that 2x minus 3. We're going to break that up into the two terms. And then we've got x plus 5. We're going to put that down the other side, x plus 5. Now when we multiply these out, we've got to multiply every possible way. All right, so what's really going on here is we're going to see that this is really distribution. We're going to distribute this 2x. That 2x is going to multiply by the x. 2x times x is 2x squared. So multiplying these two, we get 2x squared. Then we're going to multiply 2x times 5. 2x times 5 is 10x. Remember, x times x is x squared. Well, then we got to multiply the negative 3 here. Now it's got to be a negative 3. So we're going to multiply that negative 3 times x. Well, this little box here is lined up with the negative 3 and the x, like an area model. Negative 3x, kind of like a multiplication chart, I guess you can think of this. If we have the next one, negative 3 times 5, well, that's these guys, negative 3 and 5. So that's negative 15. And so what that does for us is that gives us these four terms in here are what we get when we multiply. We have 2x squared plus 10x minus 3x minus 15. And we know we can combine like terms to finish it off. Okay, so we get 2x squared, 10x minus 3x is 7x, and then minus 15. All right? And that's how we can use an area model. Let's try it again. How about if we have x plus 3 and x plus 2? Well, again, we're going to think about this. We're going to multiply this x out here by this x. Well, that's these two right here, x squared. Okay, that's x times x. Then we have the x times the 2. That's this x times the 2. So that gives us this box. 2 times x is 2x. We have this 3 here times x. So we get 3x. And we've got the 3 times the 2. 3 times the 2, like a multiplication table, gives us 6. And there's all the ingredients. There's all the pieces. So from here we get x squared plus 3x plus 2x plus 6. All right? Then we can combine these terms, and we get x squared plus 5x plus 6. So the area model is a nice way to organize it. After a little bit, you'll probably move away from this, but it's a good way to see that we're multiplying the x times both and the 3 times both. Both of them are getting distributed. Okay? How about this guy? We've got the h minus 8 and the h minus 9. Maybe pause and try this out. Maybe pause and try both these out here. See if you can do that. All right, we should get this. We multiply the h times the h, that's h squared. The h times the negative 9, that's negative 9h. The negative 8 times the h, that's negative 8h. The negative 8 times negative 9 is positive 72. So both of them get multiplied. All 2 times 2, that gives us 4 terms, all right? And so we get h squared minus 9h minus 8h plus 72. We can clean that up a little bit. We get h squared negative 9 minus 8 is negative 17. That's it. Okay. So multiply, distribute each of the terms, all right? So each of these, the h gets distributed and the 8 gets distributed, okay? One more. Maybe pause and give this a try. A little more challenging. 3k minus 1 and 4k plus 9. Well, we got to distribute the 3k times the 4k. 3 times the 4 is 12. K times the k is k squared. Then we have the 3k times the 9. That's 27k. We've got the negative 1 times the 4. K, that is. Negative 1 times the 4k. That's going to go right here. And the negative 1 times the 9. Negative 9. So again, this is just an organization tool. We're going to go ahead and write them out now. 12k squared plus 27k minus 4k minus 9. And once you get the hang of it, you can move away from the area model. And once you see that we're just distributing both of them, 12k squared, let's combine the middle. 27 minus 4 is 23k minus 9. All right, great job. So we're distributing both terms there. So that's with an area model. Kind of a nice tool. And by the way, this would work if we have like an x plus 2 times x squared plus 3x plus 1. Well, we can make an area model, x plus 2. Let's get a rectangle here. And we can break it up into 6 spots. X squared plus 3x plus 1. Okay, and we're going to multiply the x times each of these. That gives us x to the third, 3x squared plus 1x. We're going to multiply the 2 times each. 2 times the x squared plus 6x plus 2. Okay. Now, as we move away from this here, we'll just write all these terms out, all right? But anyways, x cubed plus 2x squared plus 3x squared plus 6x plus 1x plus 2. So once you get the hang of it, you can skip the drawing, and we write them out, and then we combine like terms. Those guys go together. X cubed plus 5x squared. These two go together, and we get, all right? All right. Well, another little nickname that, another useful acronym here is FOIL. Okay, we notice we multiplied the x times the x. Those are the first terms. Then we have the x times the 2. Well, those guys are like on the outside, so we can call those the outside terms. Then we're going to multiply the 1 times the x. Those are the inside. And the 1 times the 2, those are the last. So you can think of this two ways. This will get the same result. Okay. You can think of it as if we're distributing the x and distributing the 1. Okay. But this is also a nice way, and you'll hear this a lot. This is very common. First, outer, inner, last. Which ones are the first? X times x. That's x squared. Which ones are the outside? The 2 and the x. Multiply them, we get 2x. Which ones are the insides? Well, these 1 and the x are like on the inside of the problem. 1 times x is 1x. And the last is the 1 times 2, which is 2. And we put them all together, we get x squared plus 2x plus 1x plus 2. Or x squared plus 3x plus 2, because we need to add those together. All right? Great. Well, so there's that. So first, outer, inner, last, FOIL. Let's see how that works. Okay, so we can go FOIL first. You can even write it out. Outside, inner, last. What's the first ones? B times B, that's B squared. What's the outside ones? That's B times 7. So that's a plus 7B. What's the inside ones? Positive 3 times B. What's the last ones? Positive 3 times 7, which is 21. Okay? And we combine like terms, B squared plus 10B plus 21. All right? Don't forget, only combine like terms. Don't try to put anything else together. Okay? Why don't you try this one? Pause it. Try this guy. FOIL. Let's see what we get. Now you might say, well, that's just the same thing. You're right. You can think of it as FOIL or distribution. Either understanding works. K times K, those are the first ones. The outside ones, negative 1K. The inside ones, 5K. The last ones, negative 5. All right? So K squared, combine these guys, negative 1 plus 5, that's 4K minus 5. And that is simplified. All right? Well, let's finish with this, and I don't want this to get too long here. So what if we have 2 terms times 3 terms? Well, you have options. FOIL will not work here because there's 3 terms, so no FOIL, all right? FOIL, no good. Not here. So let's just think distribution now. We're just going to multiply the x by each of them. If you want to make an area model, you can. X times x squared is x to the third. X times 3x is 3x squared. X times 2 is 2x. Now distribute the 4. 4 times the x squared. And we're just listing them out rather than drawing the picture. 4x squared. 4 times 3x, 12x. 4 times 2 is 8. All right? Now, let's combine like terms. We've got x cubed. There's only one term that's an x cubed. I like to underline my terms as I take care of them. Let's put the 3x with the 3x squared with the 4x squared. That's 7x squared. Only combine like terms. 2x plus 12x, that's 14x. Let's see, did I take care of all the terms? Underline, 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 underline. Oops, I forgot one. Plus 8. Just make sure you include all the terms when you're simplifying. All right? One more here. Let's distribute. Now, you can think of this in here. This has the 3 terms first. You could flip them around and do the same kind of thing we did. Or you could distribute the y squared. Let's go y squared times y is y to the third. Y squared times 3 is 3y squared. We just got to pair all of them up. 8y times y, that's 8y squared. 8y times 3, 8 times 3 is 24y. Then we've got this negative 2. Make sure you think of it as a negative. Negative 2 times y, negative 2y. Negative 2 times 3 is negative 6. And put it all together. Combine the y squareds. That's going to give us 11y squareds. Combine the y's. 24 minus 2, 22, and a minus 6. Okay? So I didn't really underline. I kind of boxed as we went there. That's the idea. All right, hope that helps. So that's how we multiply, very important tool there. So keep working at it and you'll get it. Either use the FOIL method or the area model, or just think of it as distribution. Again, we want to eventually move away from these and just think of distribution. That's kind of the best ultimate way that will work for all different types of problems here. Well, keep working hard and you'll get it. Good work.